Okay, right. So, well, here I am, and I'm going to take up a nice and lovely puzzle, the statement of which is very simple, in fact. So, it asks you to find the maximum value of product of integers, positive integers, which add up to 100. So, what we have been given is that there are a few positive integers. So what we have been given is that there are a few positive integers which add up to 100. And what's the maximum value of their product? So something like x1 plus x2 plus so on, all the way up to xk. And they all add up to 100. So where k is greater or equal to 1. So and xi's are positive integers. So what's the maximum value of x1 times x2 times x3 times all the way up to xk? Now, how do you attack this problem? So one of the ways is that we could invoke calculus, and something which I have quite frequently said, and which I will say, is that when we invoke calculus, we sort of, if not demean ourselves or if not diminish ourselves, then we do hold other branches of mathematics in certain disdain. So what I'm going to do is that I'm not going to invoke calculus, and I'm going to use basic facts of numbers to arrive on the answer. So the first question which I'm going to ask is, so think about it, that if you're going to split these numbers into large numbers, so for example, if you were to split 100 into two 50s, the product of which would be 50 times 50, which is 2500. And if you were to sort of divide 100 into three numbers, 33, 33, 34, so their product, 33, 33, 34, is greater than 50 into 50. And you can go ahead and further say that, in fact, 25 into 25 into 25 into 25 is further greater than 33 into 33 into 34. So as you go on breaking numbers, the obvious question is that you're sort of going on the higher side of the product. And yet, if you were to atomize 100 in terms of 1, that is, that if you were to write 100 as the sum of 100 ones, the product is going to be just 1. So that is not a really fruitful uh, decomposition of 100. Right. So there is a maximum sweet somewhere in between 1 and 100. So there is this, my cat, and who is here. So the question is that how do you do this, right? So I'll submit that I'm going to begin with that I'm going to divide 100 into two 50s, not two 50s, rather 52s. That is 2 plus 2 plus 2 plus 2, 50 times. This is 100. And their product is to the power 50. I'm not claiming that this is the highest product. I am not claiming that this is the highest product. No. But what I'm going to ask myself is that, can we do something to attain the highest product from this point? So can we do some changes in this sequence of 50 equal twos to get the product as 2 to the power 50? Right? Is the motivation clear? Okay, right. So what I'm asking is that why can't you combine some of these K2s and write that as 2K, right? So the question could be asked that combine some of the 2s. And by the way, 2 to the power 50 is as good as 4 to the power 25. And 100 could be written as 4 plus 4 plus 4, 25 times. And you'd get the same answer as 2 to the power 50. And we are not claiming that there's the maximum, but we're saying that to be done this way, but no, never mind. So the question is that someone could ask, come across and ask that why 2 to the power 50? Why can't you take some of the 2's and combine it into an even number? And that's a valid proposition to begin with. Well, that shouldn't be the case, because think about it, that if I were to take K2's, right, and fuse them into one to get one singular number, which is 2K, right? So 2K, the number 2K has come at the expense of K2's. Now K2's, the product of K2's is 2 to the power k, while the number 2k in the product will just amount to 2k. You getting my point? Yeah. Now, if you look at it, then 2 to the power k is in fact greater than or equal to 2k. For all k greater than or equal to 1. So the equality holds at k equal to 1 and 2. And after k greater than 2, 2 to the power k is greater than 2k. You can see that 2 to the power 3 is 8 and 2 into 3 is 6. And now using induction, we can say that 2 to the power k is greater than 2k. So which means that if you're going to combine 2's and form even numbers, then your product is going to diminish, right? Unless you take 2k's and make that 4, which is same because we have agreed that 2 to the power 50 is equal to 4 to the power 25, right? So unless you fuse 2k's and you make this as 4, you make that as 4, and they're equal, right? So then that's the point that we're talking about. So which means that you can't take 2's and fuse them to get even number greater than 4. And we have agreed that 4 is as good as 2 squared. So we are not going to argue that why you shouldn't make 4 and why you should make 2 into 2. So they're just the same, right? It doesn't affect the product. Okay. So you shouldn't combine 2's to form odd even numbers greater than or equal to 4. Right. But that still leaves us with a possibility that why you couldn't combine 2 to make odd numbers. Oh, so the question is that how can you combine 2 to make odd numbers? Well, that's possible because uh, since the number is 100 and if you're including an odd number, so there must be even number of odd numbers because even number of odd numbers will give rise to an even sum. And the other thing is also 100. So because any number of even numbers will give you even. So the odd number of numbers must be even so that their sum is 100, which is even, right? So it's entirely possible that you might combine an odd number like this and an odd number like this. And well, and at the expense of few 2's. And the question is, how many 2's will it require to get odd numbers like these? So, well, then you will have to use exactly k plus m plus 1 2's. You will have to expand, fuse together k plus m plus 1 2's to get two odd numbers of the form 2k plus 1 and 2m plus 1, right? Because these number of 2's, they add up to 2k plus 2m plus 2. And these two odd numbers add up to 2k plus 2m plus 2. Now, what happens to the product? So let's have a look at the product. So this product becomes, the product in case of 2 becomes 2 to the power k plus m plus 1. And the product in the other case becomes, when you multiply those odd number, it becomes this. Um, right. Now the question is that which of them is greater, obviously. So if you were to put m as 1 and k as 1, you will see that this is 2 to the power 3, which is 8. And you'll see that this is 3 into 3, which is 9. So this is greater, in fact. And so our theory that it should be just 2 or our initial guess is wrong. And in fact, you can replace some of the 2's by 3's. At least this is the possibility. This is a possibility. It's entirely possible that you could fuse larger odd numbers to get a larger product. But we are going to prove in a moment that that's not possible. Why? Look at the number 2 to the power k. I'm going to argue that 2 to the power k is greater than 2k plus 1 for all k greater than or equal to 3. And that's elementary. That's something that you can check for yourself. Right. So that's something that you can check for yourself. But please go ahead and check that this is true. Similarly, since this is true, so for k equal to 3 to the power k is 8, and for k is equal to 3, 2k plus 1 is 7. And using induction, you know that if you're going to add k plus 1, so the left hand side, which is 2 to the power k, will be multiplied by 2, while the right hand side is just going to be increased by 2. So left hand side will increase far too fast than the right hand side, and we can prove it using induction. So for k greater than or equal to 3, 2 to the power k will still be greater, which means that you can't replace 2 to the power k by any odd number for k greater than or equal to 3, right? The same argument goes for 2 to the power m. Is greater than 2m plus 1 for m greater than or equal to 3, right? So now the question is that which is greater, 2 to the power k plus m plus 1 or 2m plus 1? So the only values which we need to check is that all those values of k and m which lie between 1 and 3, 1 and 2 rather, because for any other thing other than 1 and 2, 2 to the power k becomes greater than 2k plus 1, right? So you can check. Put k is equal to m equal to 1, and we have already seen that this number is greater than that number. This number is greater than this number. Put k equal to 1 and m equal to 2, and you'll get this number as 3 and this number is 5. So this side becomes 15, while this side becomes 2 to the power 4, which is 16. That doesn't hold good. K equal to 2, m equal to 1 is the same story. It doesn't hold good. And now you can try that. What if k is 1 and m is anything greater than or equal to 3? That's also a possibility. You can try that case as well, and you'll see that that doesn't hold good, right? And therefore, we're done. So what we're going to do is that we are going to replace 2's by a bunch of 3's to maximize the product, right? And the way to do this is that we know that 2 plus 2 plus 2 is 3 plus 3. So in our original product, we can replace 2 to the power 3 by 3 to the power 2, right? So the answer is not 2 to the power 50. What we can do is that we can say that this 2 to the power 50 contains 2 to the power 48 into 2 to the power 2. And 2 to the power 48 is in fact 2 to the power 3 to the power 6 into 2 to the power 2. And so this will be greater than, in fact, this will be in fact less than 2 to the power 3 is less than 3 to the power 2. And something like that, right? This should be 16 rather. So the maximum value is going to be 3 to the power 48 into 2 to the power 2. And yeah, that's that. So that's the answer. I hope you liked it.